Section 3.1 to 3.2 review. Calculators are allowed but not necessary on these particular problems. So this one says we want to determine the value of each of the following, and if we look, they are all limits as h approaches 0 where h is on the denominator. So if this were a section 2.3 problem, we would probably want to expand all of this, combine our like terms, and hope that everything without an h would cancel on the top so that we could factor an h and then reduce and compute the limit. The problem with that is that it will work, but it'll take a really long time. And we can see that we are much more efficient if we can recognize what this is representing. If we look carefully, it looks an awful lot like a y-coordinate minus a y-coordinate over an x-coordinate minus an x-coordinate, which is a secant slope, and then we're taking a limit as h approaches 0, so those innards of the functions are getting closer and closer. So this is actually a function's derivative at 1/3. So if we can figure out what the function is and then take the derivative using our shortcut rules, then all we will need to do is plug in that 1/3. So how do we recognize what the function is? Let's remember that our derivative for any function at any point will be defined as this, that f of a plus h minus f of a over h. So if we look here, we can see that this piece right here is going to be the f of a plus h. We can see that the a is the 1/3, and if we replace the a plus h with an x, then we can see that the function is 5x squared. So now if I take the derivative of that, I will get a 10x, and if I plug in a 1/3, I'll have a 10 times a 1/3, or 10/3. So let's look at B. Again, same issue. The goal is to identify, first of all, what the a is, and we can see that right here. It's a 1.1. And then to identify what the f of a plus h is. So if we look here, we've got an a plus h and we've got another a plus h. So that means this whole thing here is our function evaluated at a plus h. So if I replace the a plus h's with an x, then I'll end up getting a function of x that is 10x to the 4th minus 10x cubed. So now if I take my derivative, I'll get a 40x cubed minus a 30x squared, and then I need to evaluate it at 1.1. So I plug in my 1.1, and then I use my calculator to compute it, and I end up with a 16.94. I will trust you can put that in your calculator. Okay, so last one, little bit trickier, because my a in this case is an x. So that means this entire thing is just representing the derivative at x. So let's identify the function. If we look carefully, we can see there's an x plus h here and an x plus h here. But then I can see there's a 3x to the 4th, and here's another 3x to the 4th. So that means this 5 and this negative 5, this 5 is part of the function. So we can see here that I've subtracted a 3x to the 4th minus a 2x squared plus a 5. So here was my f of a plus h, then I subtracted, or excuse me, my f of x plus h, and I subtracted my f of x. So f of x is actually going to be that 3x to the 4th minus 2x squared plus 5. Therefore, the derivative will be 12x cubed minus 4x plus 0. And I don't think I plug anything into that.